I'm Anil Kumar, and in this video we will understand combination of functions and their domain and range. We have taken an example where f of x is equals to x squared minus 4 and g of x is x plus 2. Now when we say combination, in that case what are we working with? We are working with operations like addition, subtraction, multiplication and division. This is kind of combination, right? So what you can do is that you can find what is f of x plus g of x. You could find what is f of x minus g of x, or you could find what is f of x times g of x, or even what is f of x divided by g of x. These are different combinations. You can change the order and do some more combinations with these functions. So what we will do here is we'll look into some of these combinations, right? Let me begin with f of x plus g of x. What is that equals to? Simply add them. That is what it means, right? Now, whenever we are working on combination, we can perform all these operations on common domain, right? So we should have common domain. That is very important. Now fortunately for us, both the functions, the domain is x belongs to real numbers, and therefore that is the common domain. So we can perform all these operations in this domain of x belongs to real numbers. There will be some restrictions in when we do quotient. We'll look into that in details later. Okay, so let's begin by the combination, which is sum of these two functions. So let's write down x squared minus 4 plus g of x means plus x plus 2, right? Now that becomes a quadratic equation which I could rearrange and write as x squared plus x minus 2. Now that is minus 2. So we can factor this and write this as x plus 2 times x minus 1, right? So that becomes the quadratic function, right? Now from this function you can always write domain and range for the function. Let me sketch these functions over here one by one, and then we'll write domain and range for these functions. So this one is x plus 2 times x minus 1. That means zeros at minus 2 and at plus 1, and the minimum value, since it opens upwards, right? So this will kind of opens upwards, right? Its minimum value will be midway somewhere, correct? The value should be at which point? Axis of symmetry in this case will be minus 2 plus 1 divided by 2, right? So that is, so we can do 1 minus 2 equals to divided by 2 is minus half. So at minus half we have the vertex. Let's find out the value of the vertex. So we have minus half plus 2 and minus half minus 1. So when I do minus half plus 2, I get 1.5. I can treat this as 0.5, right? Change it to decimals. So minus 0.5. So this value will be at, let us write down the value here. We'll calculate and write it down. So I'll write here what is f of minus 0.5. I should not say f. Let us say this function is hx equals to, so let me write h of, right? So we'll just calculate the value at minus 0.5. So if I write minus 0.5 plus 2 times minus 0.5 minus 1, I get 1.5 times 1.5 with the negative side, right? So it is basically negative value, but it's 1.5 whole square, and that is in decimals 2.25. You get an idea, right? So this value here is 2.25, and therefore for this function, which is f plus g, we can write that the domain is x belongs to real numbers and the range is y belongs to real numbers where y is greater than or equals to 2.25. You get an idea, right? So that is how we could write domain range for this particular function, right? You can do the same calculations for takeaway. So you just write minus x minus 2. You'll get your function, sketch that function, and find domain range. Yes, it will be a parabola, right? Now let us try to do product of these two functions, right? I'm leaving that for you. Product means just multiply them, right? So f of x times g of x will be x squared minus 4 times x plus 2, right? So that is what the function is going to be, right? Now if I factor this, I could write this as x minus 2 times x plus 2 times x plus 2. That means it becomes square, right? So let me sketch this function here. So we have x minus 2. It's a cubic function, positive leading coefficient, right? So 1, 0 is at plus 2. The other one is at minus 2, right? So plus 2 and minus 2. At plus 2, it is a linear 0, right? And at minus 2, it is quadratic, so it will bounce back, correct? Now, between these two zeros, we can find the x-intercept, right? So the x-intercept will be, when I substitute 0 here, I get this 2 squared is 4. 4 times 2 is minus 8. So we could sketch this function kind of like this, right? Where this value will be minus 8. Anyway, from domain and range point of view, that is not very critical, since what we observe here is that both domain and range are real numbers. This is a cubic function, right? So we are doing f of x times g of x, right? Here we have domain, which is x belongs to real numbers, and range, which is y belongs to real numbers, correct? So both are all real numbers. So that is what you get when you do product of these two functions, the cubic functions. Now let us consider f of x over g of x. F of x is x squared minus 4. G of x is x plus 2. We could factor and write this as x plus 2 times, x minus 2 divided by x plus 2. Now x plus 2 cancels out. So you are left with x minus 2, and of course there's a restriction that x is not equal to minus 2. That actually gives us a whole, right? So because they cancel out. So let me sketch this function also, and then we will see its domain and range. So it is x minus 2. That means at minus 2 we have y-intercept. So it is a straight line with slope of 1, right? So it's kind of like this. However, at x equals to minus 2, there is a hole. So if I write minus 2 here, I get minus 4. So let us assume that this is minus 2 for us. Then at minus 2, we have a hole. Do you get the idea? And therefore, strictly speaking, the correct graph is a straight line with a hole at minus 2. Do you get the idea, right? So it is different from x minus 2. It has a restriction, right? Now, from here, we can write domain as x belongs to real numbers, where x is not equal to minus 2. You get an idea, right? So that is the restriction. And as far as the range is concerned, range is y belongs to real numbers, but y is not equal to, the value is minus 4, right? It's minus 4. Correct. So that is how you find that when you divide these functions, or the quotient of these functions will have a restriction in the domain, since the denominator cannot be 0. And from the sketch, you know that the function is a straight line with a hole at x equals to minus 2. So domain has a restriction that x cannot be minus 2, and range has a restriction that y cannot be the value of that quotient at minus 2, which is minus 4. I hope this helps you to understand how to find combination of functions and their domain and range. Thank you and all the best.